So now we're going to look at proportions and problem solving. So we've been working with rational expressions, rational equations. Now we're going to utilize these to problem solve, starting with proportions. So proportions, we've got two things happening here. We've got a ratio, which is the quotient. Quotient, of course, means division. Quotient of two numbers or quantities. Okay, so example, 2 to 5 as a ratio is just 2 over 5, okay? 2 to 5 as a ratio is just 2 over 5. So that's going to be a ratio. Now, a proportion is a mathematical, okay, it's a mathematical statement that two ratios are equal. Okay, so 1 over 2 equal to 4 over 8. So that's kind of the difference between an expression and an equation. When you're talking about a ratio, you're just talking about a single piece of it. 2 to 5 is a ratio. And a proportion is going to be one ratio equal to another ratio. So that's what we're looking at. We're going to be using that a lot. With these, we can use cross products. Okay, if A over B is equal to C over D, then A times D is equal to B times C. Okay, why does this happen? Let me show you very quickly, and then we will just use the cross multiplying method. So here, if I wanted to get B from on bottom, I would multiply both sides by B. Okay, so then I would get A is equal to C times B over D, and then if I wanted to get rid of D, I would multiply both sides by D, so that those crossed out, and I would get AD equal to CB or BC. Order doesn't matter there. So that's basically what happens is if I want to get rid of the division, I would multiply, and we're just doing it twice both directions. So we can cross multiply. A lot of people call it the butterfly method because you're going across and you make a little butterfly. Most important thing about this is that you must have an equal sign in the middle here. If it's a plus or a minus, you cannot cross multiply. Only across an equal sign can you do cross multiplication. Okay, and that is extremely important. You have to add and subtract things the way we learned in the last unit, but once you get to where this piece is equal to this piece, then and only then can I cross multiply. It's got to be able to make this nice, pretty little butterfly with an equal sign in the middle. So for example 1, this is super easy because this is going to be that butterfly. Okay, because I've got a ratio equal to a ratio. This is considered a proportion. Okay, a ratio equal to a ratio. So we can cross multiply. So 5 times x, or x times 5, is 5x. Doesn't matter the order. And 45 times 7, okay, 45 times 7 is what goes over here. So here, that would be 5x is equal to 315. Divide by 5. And x is equal to 63. Okay, x is equal to 63. We still have to be worried about extraneous solutions because I do have an x on bottom, but if I were to plug that in, I am not going to get 0, so I am okay there. So same thing here, okay? I would suggest that you hit the pause button for a second, see if you can try this real quickly. Shouldn't take too long. Okay, when you come back, then you can check and make sure you got the right answer. I'm going to continue on. I have a proportion or a ratio equal to a ratio, so I can cross multiply. No, you do not have to create the cute little butterfly with the little, you can put little antennas on it if you'd like. Okay, you definitely don't have to do that. You can just multiply it out. So x times 5 is 5x, and 10 times 3 is 30. Okay, divide by 5, x is equal to 6. Now you're probably wondering, here on the first one, I did the bottom first. I got 5x equal to 315. And here I went to the top first and did 5x equal to 30. It doesn't matter. Okay, 30 equal to 5x is exactly the same as 5x is equal to 30. I get the same answer either way, just written backwards. So it's not going to make any difference which way I go. It is important, however, that I go bottom times top and bottom times top. Okay, bottom times top. That's super important. These two have to multiply together. These two have to multiply together. Okay, can't multiply vertically or anything crazy like that. You definitely have to make your cute little butterfly as far as the pattern goes. So, Now example 2, okay, now we want to be able to use this information. So this is how you solve a proportion, but now we want to be able to set up our own proportions. Lots of problem solving in this particular unit, okay? I know how exciting that is for all of you, but I'm going to show you how to do them. I'm going to show you lots of examples so you can kind of go by that. So here we go. 3 boxes of CDRs. Those would be recordable compact discs. For those of you who don't know, those would be those shiny little circle things that you throw in your computer. Okay, and they cost $37.47. How much should 5 boxes cost? The biggest part of setting these things up is to make sure you are consistent with your units, okay? So I am going to do boxes over cost. Okay, I can choose to do cost over boxes. It will not make a difference. I will get the same answer. The important part is that I am very consistent. Okay, so 3 boxes, okay, for $37.47. 5 boxes for our unknown. We don't know how much it's going to cost. Again, I could have set it up cost over boxes. Okay, that is per boxes, can't spell. Cost over boxes and done $37.47 over 3 is equal to X over 5. That is perfectly fine as well, as long as you are consistent. Can't have boxes over money equal to money over boxes. You can't split them like that. Okay, after that, it is a proportion, so we can butterfly this thing. Okay, cross multiply. So I get 3x equal to 37.47 times 5 is 187.35. Okay, obviously 2 decimal points here because we're talking about money. We're going to keep it logical. Then we would divide that out by 3. X is equal to 62.45. Okay, once you get this part down, you get it set up and you do your cross multiplication. After that, it's really just kind of punching stuff into a calculator. Okay, divide both sides by 3 and there's your answer, 62.45. So, example 3, same sort of thing. There are 110 calories per 28.4 grams of crispy rice cereal. Find how many calories are in 42.6 grams of this cereal. Okay, so we've got calories, we've got grams. Okay, doesn't matter which way you set it up as long as you're consistent. Calories over grams is what I'm going to go with just because that's the way it's listed out. So 110 calories over 28.4 grams is equal to, okay, find how many calories are in 42.6 grams. So how many calories in 42.6 grams? Calories over grams, calories over grams. We know it's proportional because it's not like the crispy rice is suddenly going to get more fattening just because there's more of it, okay? You're still going to have the same proportion happening, which is what you're doing. Okay, so now we cross multiply. So that is going to give me 110 times 42.6 is 4,686. Okay, and 28.4x is just 28.4x. Divide that side, both sides by 28.4. 28.4. Okay, divide both sides by 28.4, and I would get x is equal to 165. Okay, 165 what? X was our calories. Okay, X was our calories. It is very important in this unit that you actually label things to make sure that you have the right thing. Speaking of, this should have been, I forgot my dollar sign, shame on me, $62.45. Here we've got 165 calories for 42.6 grams of this cereal. Okay, here's the on your own. I would suggest you hit the little pause button. Give this one a shot, see if you can get it set up, see if you can get it solved, and then come back and see if your answer matches up with mine. Okay, so moving on for me, a pack of 10 rolls of paper towels cost $12.95. How much should a pack of 3 cost? Okay, how much should a pack of 3 cost? So I'm going to go with rolls over cost this time. Okay, so 10 rolls is $12.95. equal to how much should a pack of 3 cost? So 3 rolls for however much money, we don't know yet. We're about to find out after we cross multiply this thing. Okay, so we go with 10x equal to 38.85. Okay, that's just 12.95 times 3. Divide that by 10, and I get x is equal to $3.89. We're going to go ahead and round up there, $3.89. Okay, going to 2 decimal points because it's money. Make it logical. It is money. It should have cents. Okay, so next one, here's another one on your own. Again, I would go ahead and give this one a shot. If you haven't already tried it, hit pause, give it a shot, okay, then come back and see if you can match up with what I'm doing. Manufacturer of cans of salted mixed nuts state that the ratio of peanuts to other nuts is 3:1. Okay, so we've got a ratio, and it is peanuts to other. They tell you which way this thing is set up. So here, we don't have an option like we did with rolls and costs. I could have switched it over and done costs and rolls. Okay, I guess we could technically switch this to do 2/3, but it has to follow with the 3 is for peanuts and 2 is for the other. Okay, so we've got 3:2 is equal to 324 peanuts are in the can. How many other nuts should there be? Okay, we've got 324 peanuts. How many others should they be? I have it all set up. 3:2 is equal to 324 over x. Let's go ahead and cross multiply this thing. 3x is equal to 648. Divide both sides by 3, and you get x is equal to 216 other nuts. Okay, other nuts. Apparently they were not important enough to say exactly what they were, just other. Okay, 216 other nuts is what should be in the can. Doesn't say that it necessarily is, but that's what should be in there. Okay, now we also have something called triangles. Okay, not something called triangles like you don't know what a triangle is. We can also do this with triangles is what I'm trying to say. Okay, if we consider them to be similar triangles. Okay, similar triangles means that they are proportionate. Okay, they are proportional, meaning that the ratios are going to be equal to each other. Okay, so the ratios. Now again, the big part here is being consistent. Okay, you have to be very consistent. These things are drawn out in a way so that you can say that these two go together. Okay, these two go together, and these two go together. Okay, they are drawn out in that manner for a specific reason. Okay, if you're not sure, going back to your geometry, this says A, B, C, and X, Y, Z. So they tell you exactly which order to go in. A, B, C, X, Y, Z. So that means that X, Y, and A, B are similar. B, C, and Y, Z are similar. And that would make Z, X, and C, A also similar. So similar triangles means the ratios are going to be proportionate. There are 2 different ways you can do it. Okay, I can either do the big side over the big side and the big side and the little side over the little side, set those equal, or I can go big over little is equal to big over little. It just depends on which way you want to do it. So for instance here, if I want to find the measure of side Y, so I'm looking for this guy right here, I just need to pick, okay, the side that's proportionate with it, definitely. Okay, I have this one here. So I'm going to have to use these 2 because we have to use the proportionate sides. Okay, so these 2 sides, and then I just pick 2 other sides. It doesn't matter which ones I pick. Okay, for instance, let's say I go with this one, and then I have to use this one. Okay, I can't use like this one and this one. They have to be consistent. Okay, and let's say I go... we'll do this by letter. I'm sorry, I'm trying to figure out which way I want to label it. So I'm going to go big over big, equal to small over small. Okay, what do I mean by that? So I have to use these ones. These are the ones I've decided to use. So I'm going to go with big over big equal to small over small. Okay, but I want to talk about this because this is going to be one of the parts that gets people sometimes. Is that, sorry, my screen froze again. Is that when I go to look at these, I have to, both of these are on top, both of these are on bottom. My bigs are over here, my smalls are over here. Okay, you have to be very consistent with the way you put these in. This is how the proportions work. 12 over 15 is equal to y over 5. Once I'm here, now I can cross multiply. Okay, now I can go ahead and cross multiply. So I get 15y is equal to 60. Divide by 15. Y is equal to 4, and these are inches. Okay, y is equal to 4, and those are in inches. Now I want to show you, just for your own knowledge. So I could have set this up many ways, I told you that. Okay, so this is a second method. I don't want you to think I'm doing anything different. I'm just going to set it up a little bit different. I still have to use these two because this is what I'm looking for. Okay, so this time I'm going to go this over this. Okay, the small over the large, y over 12 equal to, okay, then I got to go small over large again, 5 over 15. I could have used these too, okay, but I'm just choosing to use these. So I'm going to go y over 12 is equal to 5 over 15 this time. 15y is equal to 60. Okay, notice that at this step I'm the same again. Y is still equal to 4. Okay, so there's a second one that I could have set up. The important part is that you're consistent. I could have gone 5 over y is equal to 15 over 12. I'm still going to get the same answer every single time as long as I stay consistent. Okay, if I do this over this equal to this over this, you have to stay consistent. Okay, so for this next one, they want us to find x. So I know I'm using the 10 yards because those are my similar triangles. Okay, those are my similar sides. So let's just go ahead and do those. X over 10. Okay, so I've got big over small this time is what I'm looking at. X over 10 is equal to, okay, I'm going to have to use this side because they didn't give me this side. I don't know what this is, so I can't use the 9. Okay, so I have to use the 3 and the 2. And I have to go big over small. Okay, I can't go small over big because this one was big over small. That's what I'm talking about with consistency. X over 10 is equal to 3 over 2. Another option I could have done was x over 3 is equal to 10 over 2. Okay, I'm just trying to show you is equal to 10 over 2. That would have worked. I could have also done 3 over x equal to 2 over 10. There's multiple options here. Okay, you just have to pick one and stay consistent with it. And then we are going to cross multiply 2x equal to 30, divide by 2, x is equal to 15. Okay, so you could have set up multiple proportions. You're going to get the exact same answer, 15 yards. Okay, 15 yards is what we're looking at. So hit the pause button. Okay, come back, see if you can get the same answer. Remember, your equations might not look identical, but see if you can get the same answer. So don't just start erasing things till you see what my actual answer is. Okay, hit pause, come back. We're going to keep on going here. So I'm going to go large over small again. So x over 9 is equal to 24 over 16. X over 9 is 24 over 16. Cross multiply, 16x is equal to 9 times 24, which is 216. Okay, divide that by 16. X is equal to 13.5. Yes, you can actually use decimals in this unit. That should make you very excited. Okay, sorry, hopefully you could see that. X over 9, I did big over small is equal to big over small. Cross multiplied, 16x is equal to 216. Divide both sides by 16, x is equal to 13.5. We don't have any units on this one, so we're just going to leave it at 13.5. Okay, come over here. Following triangle, two triangles are similar. Find the missing length x. there are two x's because they are both the same size, so it doesn't matter which one you choose. Okay, they're both going to be the same because these two are the same, so these two must be the same, and they're both x's. So I'm going to use these ones. Okay, here I'll set it up within my triangle this time, just to show you it can be done differently. X over 14 is equal to 4 over 7. Okay, x over 14 is equal to 4 over 7. Most of you can probably already figure out what that number is supposed to be, but I'm still going to work it out just the same. Cross multiply. Here goes my butterfly. Throw some antennas on this one just because they're cute. Okay, so I get 7x is equal to 14 times 4 is 56. Divide by 7. X is equal to 8. Again, we don't have any... X is equal to 8, sorry, I'm working on the bottom here. We don't have any units to write down, so we're just going to leave it at x is equal to 8. Okay, so example 6 here. Okay, these are our work rate problems. Example 6, can we see it? Okay, example 6 is a work rate problem. So, let's go through it, pull out all the information that we have. Keep in mind that there's going to be proportions, they're going to be rational equations, so you should definitely have fractions in these. Okay, so Sam and Frank work in a plant that manufactures automobiles. Sam can complete a quality control tour of the plant in 3 hours. Okay, so let's write that down. Sam can do 1 tour in 3 hours. Okay, while his assistant Frank needs 7 hours. Okay, so Frank does 1 tour in 7 hours. Slow Frank, he must have a hobble or something. Okay, maybe he's just more diligent at his job. Maybe he shows more stuff. Who knows? But Frank takes 7 hours, okay? The regional manager is coming to inspect the plant facility, so both Sam and Frank are directed to complete a quality control tour together. How long will this take? Okay, so they're going to work together. Okay, so if we're working together on something, this is obviously going to speed things up. Now, most common misconception is to add them and divide them by 2, okay? We are not doing an average here, because you've got to imagine that if Sam takes 3 hours all by himself, then if Frank comes and helps, surely they're going to get it done faster, even if Frank is slow. Okay? Even if Frank is super slow and he barely does anything in that 3 hours, it's still going to be faster than Sam doing it by himself because now he has help. And that's the basic principle that's happening here. So together, we can do 1 tour in X amount of hours. Okay, so together we're going to do 1 tour in X amount of hours. Now together should tip you off that we are going to be adding. Okay, we're going to put together their time. So if I have 1 tour in 3 hours plus 1 tour in 7 hours, and that's going to be 1 tour in how many hours? We don't know. Okay, this is what we did in the very first part of this unit, 7.5, is learning how to solve these. Okay, so we need a common denominator. Okay, 3, 7, and x, so 3 and 7 would be 21x. 21x, right? Because common denominator between 3 and 7 is going to be 21, and then you have to have an x there. So this needs 7x top and bottom. This needs a 3x top and bottom. This needs the whole 21, but it's already got its own x. It doesn't need another one. Okay, so we get 7x over 21x plus 3x over 21x equal to 21 over 21x. Well, if you remember from the last part, now our denominators are the same, and we have that equal sign. We can go ahead and just cross those out. Okay, cross those out. And what I'm left with is 7x plus 3x is equal to 21. Okay, 7 plus 3 is going to be 10x is equal to 21 divided by 10. X is equal to 2.1 hours. Okay, because that's what we were looking for, right? X was our hours. So 2.1 hours, which is logical, and you do need to check and make sure it's logical. If it takes Sam 3 hours all by himself, if Frank helps, even if he's slow, okay, it's going to be less, which it is. We got 2.1 hours now we can work on this thing together. Okay, hit the pause button again, come back, see if you can do the on your own. Okay, see if you can do these things on your own, because it's not going to be good to just keep writing down what I'm saying. You want to try these things. That way you can kind of keep straight what you do with which types of problems, okay, because there's going to be a lot of different types of problems. So, Miss Smith balances the company's books in 8 hours. Okay, she can balance the books in 8 hours. So that's essentially Miss Smith. We'll write that down. Okay, she's going to do one set of books in 8 hours. It takes her assistant 12 hours to do the same job. So assistant, okay, I guess that's why she's an assistant, not the head person, right? She does that same set of books in 12 hours. Okay, if they work together, find how long it takes them to balance the books. So together, we don't really know yet. 1 over X hours. Okay, do you see the process? Hopefully by now you're starting to see these are called work rate problems. So one job for her equal to one job for her. We're going to add these things together. So 1 over 8 plus 1 over 12 is going to be 1 over X. Solve for X. We do that by finding our common denominator first. Okay, between 8, 12, and X is going to be 24X, because 8 goes into 24, 12 goes into 24, X goes into 24X. So this needs 3X, top and bottom. This needs 2X, top and bottom. This needs the whole 24. Okay, so we get 3X over 24X plus 2 over 24X equal to 24 over 24X. Please don't get to this point, start crossing things out of the top and the bottom and all that stuff. We want to get rid of all of our denominators. And we've got 3X plus 2 is equal to 24. Finish solving. 3X is equal to 22. Divide by 3. X is equal to X is equal to 4.8 hours. Okay, X is equal to 4.8 hours. I got to grab a calculator and double check that. 22 divided by 3 is not 4.8 hours. Sorry, I'm looking at something up here that seems to be inconsistent with something that I have. So I'm going to double check what I have here very quickly. They're going to 48, 2X and 4X. And I can see my problem already because here I was supposed to do by 2X. That's horrible. So sorry. I missed my X, so let me come back, rewind real quick. I multiplied in a 2X here to give me my common denominator, and I forgot to multiply the X on top. So this should be 3X plus 2X is equal to 24, which gives me 5X, which is then equal to 24, and X is equal to, now we should get 4.8. Let's double check. 24 divided by 5 is 4.8 hours. There we go. Okay, so we've got 4.8 hours is how long it will take them together. Does seem reasonable. She can do it in 12 hours. Miss Smith can do it in 8. Miss Smith could do it in 8 and the assistant 12. So together they can get it done in 4.8 hours. Pretty good timing. Very helpful little assistant. Okay, so now we've got another type of problem. A car travels 180 miles in the same time that a truck travels 120 miles. If the car speed is 20 miles per hour faster than the truck's, find the car speed and the truck speed. Okay, find the car speed and the truck speed. So this is going to be a lot like the triangles that we set up. Okay, it is going to be a proportion. And the easiest way to make sure that you stay consistent, because remember these things are all about staying consistent with your ratios. is to write, we've got car and truck. Okay, that's going to be my two different pieces. I've got car and truck, and I've got distance, and I have speed. Okay, distance, and I have speed. So starting with the car is going to go 180 miles, and the truck is going to go 120 miles. If the car's speed is 20 miles per hour faster than the truck's speed, okay, the car's speed is 20 miles per hour faster than the truck's speed. Hold on, my thing froze again. Make sure I'm actually doing this on the screen. So, what we know nothing about here is the truck speed. Okay, I know the car speed is 20 miles per hour faster than the truck, but I don't know how fast the truck is going. So the truck we're going to call our X, and that makes the car X plus 20, because the car is going 20 miles per hour faster than that car. Okay, so truck we don't know, car we know is 20 miles per hour faster than the one we don't know. So this is our setup. So now it's very easy, once I have it listed out like this, just write it as a ratio. 180 over 120 is equal to X plus 20 over X. Okay, I just took this, I basically threw a fraction and threw an equal sign in between them. That's what we're working with. That's why we kind of write it out like this. Makes it very nice, very organized, and allows us to look back and say, okay, which was my X? Was my X my truck speed or my car speed? Okay, this makes this very easy to follow. So, from there we cross multiply, because this is a proportion. I got something, a ratio equal to another ratio. So I get 180x is equal to 120 times x plus 20. Now you are going to have to distribute here. So 180x is equal to 120x plus 2400. Subtract the 120. And I get 60x is equal to 2400. Divide by 60. Divide by 60. X is equal to 40. Okay. And what was x? That was miles per hour. Now, find the car speed and the truck speed. This is going to get a lot of people on the test if you're not very careful. They want both. So you have to figure out, what did I find? What do I still need to find? And you want to actually label them. If you get to the end and you say 40 and 60, okay, you're going to lose points because you didn't tell me 40 is which 40 goes with which one, 60 goes with which one. So you need to actually write it out. Okay? So the car and the truck speed. Okay, we've got the car and the truck. Now we just found the truck speed. That was our X. You can look back at your little diagram here and see that the X was our truck speed, so 40 miles per hour there. And that makes our car 40 plus 20, which is going to be 60 miles per hour. Okay, the 40 plus 20 is the 60. So that's where this comes in handy. I can come back and say, okay, X was truck, so my car was 20, X plus 20, so we can kind of just add those up. There's my answer. Yes, your answer should look like this when you actually take the test or do your homework. You need to show which one is which. Don't just write 40 and 60 because I can't tell if you know which one is which. Moving on, and hopefully this whole entire video will actually fit on, yep, we're almost there. Okay, so a walker travels 3.6 miles. This is the on your own, so I would suggest and highly suggest that you hit pause here and go ahead and see if you can do it on your own. Okay, that's why it's called on your own. You definitely want to be able to do these things. Okay, so a walker travels 3.6 miles in the same time that a jogger travels 6 miles. If the walker's speed is 2 miles per hour less than the jogger's speed, find the speed of the walker and the speed of the jogger. Okay, set it up. I got a walker. I have a jogger. Okay, just pulling out important information. I got a walker. I got a jogger. Okay, I am looking at distance. Alright, 3.6 miles, travel 6 miles, and speed. Okay, distance and speed. I got a walker and a jogger. I've got distance and speed. Fill in everything you know, and then figure out the rest. Alright, so a walker travels 3.6 miles. and the same time that a jogger travels 6 miles. I want to point out something. The reason why we can set these up as proportions is this little thing right here. Okay? Because the walker does this in the same time that the jogger does this. That's the only reason why we are allowed to set these things up equal to each other. If you're in physics, or if you've been in physics, okay, when you did stuff like this, the only way that works is if one of your variables is actually equal to each other. In this case, the time is equal to each other, so we can set them equal. So keep that in mind. That's what allows us to do this, is that little thing right there. It says these things are done in the same time, which means they have to be proportionate. Okay? So, moving on. If the walker's speed is 2 miles per hour less than the jogger's speed, find the speed of the walker and the speed of the jogger. Okay? I don't know the speed of my jogger. I'm going to call him X. The walker's speed is 2 miles per hour less than that. X minus 2. Now, some of you may be wondering, couldn't I just say I don't know the walker's speed and I know the jogger's speed has to be 2 miles an hour faster? If I do this as X and this is X plus 2, I will get the same answer. Okay? I'm going to go with this just because of that keyword less. I'm going to go with a minus. So, I have this. Set up my proportion. 3.6 over 6 is equal to X minus 2 over X. Okay, cross multiply, comes the butterfly. 3.6x is equal to 6 times x minus 2. So I get 3.6x is equal to 6x minus 12. Okay, I need to solve. Okay, I need to solve. I'm going to subtract this over here. Okay, you might be thinking, but I'm going to end up with a negative x, but it's okay because I got a negative 12 on the other side, so when I divide it, it'll be all right. So I get negative 2.4x is equal to negative 12. Here's what I'm talking about when I divide by a negative. Okay, divide by a negative, and I get x is equal to 5. Okay, x is equal to 5. So, what was x? X was my jogger's speed. So the jogger is working with, miles per hour. Okay, so the jogger is going to be 5 miles per hour. And my walker makes them at 3 miles per hour. Be logical here. If you get that your jogger is moving slower than your walker, there's probably an issue. Okay, last time I checked, the whole point of jogging is to go faster than walking. So, be logical. If you get that your jogger is running at 63 miles per hour, it's probably not correct. You need to go back, check your numbers again, okay? Think logically. Just because it's math class doesn't mean you can just throw real life out of the way. Think about real life. What makes sense to you? Okay, see if these things actually make sense. Now, the very last type of problem. Okay, the very last type of problem. Yes, it is the more difficult one. That's typically how it goes. We start off easy, we get harder. That's how this class works, right? So, same sort of organization, though. I've got a boat traveling upstream 55 miles. And the same amount of time, there's that key word there again, same amount of time. Didn't even do it all. And it travels downstream 80 miles. Okay, so we go upstream 55 miles and the same time that it goes downstream 80 miles. If the stream is moving at a rate of 5 miles per hour, and we'll talk about what to do with this in a second, find the rate of the boat in still water. Okay, so in still water means if it's just sitting in a lake that's not moving, how fast is this thing going? Okay? Because you got to imagine that if I got water moving underneath me, it's kind of like, think about walking on one of those little moving sidewalks. Okay? I'm walking at the same rate, but I'm moving very quickly with proportion to people standing on the side. Okay? I'm moving very quickly. That's exactly what's happening with the stream, going upstream and downstream. Okay? If I'm moving with the water, then I'm going to be moving very quickly in respect to things sitting off to the side versus if I was moving in still water. So that's what we're looking at. Okay, we're still going to set it up in the same sort of manner. So I've got an upstream and I have a downstream. Okay, I have a distance and I have a speed. Okay, so we're still setting it up same sort of order. So upstream we go 55. Downstream I go 80. Okay, now the speed. Now you have to imagine that if I am going upstream means I am going against the current. Okay, upstream means against the current. Okay, upstream means against a current. So if I'm going against a current, then I'm going to have my speed minus the speed of the water. Okay, because the water here is going to slow us down by how fast it's going. So by 5 miles per hour, that's how quickly the water is slowing us down. So we are fighting against the water moving upstream. Now downstream, it's pushing us. This is getting on that walking sidewalk, right? Okay, x plus 5. X plus 5. Okay, so it's going to be moving us at a rate of 5 miles per hour plus what we're doing. Okay, so the water speeds us up. Okay, water speeds us up by 5 miles per hour. Again, a good way to think about this, if you've never actually been on a boat or on a stream or a river or something like that, would be most of us have been to the airport and been on those awesome little walking sidewalks, or been in the mall and been on an escalator. Okay, think about if you're standing still on an escalator, you're moving at a certain rate, but if I start walking up the escalator, now I'm moving quicker. Okay, not just my speed, but my speed plus the speed of the escalator. Now if I start going down the escalator, okay, now I'm talking about that's like moving upstream, okay, because upstream is against the current. So now I'm talking about I have my speed minus the speed of that thing, okay? So I might be running down, okay, but I'm not going anywhere if I'm moving at the same rate. So that's what we're looking at, okay? So you might want to make a little note to yourself that x is going to be the boat speed in still water. That's what our x actually stands for, still water. Still H2O, little chemistry for you there today. Okay, so we're going to be in still water. So set it up as a proportion just like we have everything else. 55 over 80 is equal to x minus 5 over x plus 5. Go ahead and do your cross multiply. It's a big old butterfly this time. Okay, so I've got 55 times x plus 5 equal to 80 times x minus 5. Okay, go ahead and multiply that out. 55x plus 275 is equal to 80x minus 400. Solve for x. Okay, I'm going to move this way, minus 55x, which means this needs to move the other way, so plus 400. So I get 675 is equal to a 25x, divide by 25, divide by 25, x is equal to 27. And what was 27? 27 would be the boat speed in still water, so it's 27 miles per hour. Okay, 27 miles per hour. So if I was sitting on a lake at going that speed, okay, putting that same amount of force into the boat, I would go 27 miles per hour. All right, you have one left to do there. Okay, hit pause, give this one a try. Very quickly, just in case you don't know, because a lot of people don't. Okay, this one says with the wind and against the wind, but just for your future information, if it says tailwind, okay, a tailwind, because I believe this might show up in homework, but a tailwind is from, is going to be with the wind, okay, because that's going to be blowing from behind you, so it's pushing you, and a headwind is going to be blowing in your face, so that's against the wind. Okay, I believe that might show up in your homework somewhere, so keep that in mind. A headwind is against the wind, and a tailwind is with the wind. So, hopefully you've hit pause. Hopefully this is you coming back after you've completed this problem and you totally understand it. At least that's what I'm hoping for. So, against the wind and with the wind. Okay, against the wind helps by right wind. Against the wind and with the wind, that's what we're looking at. A pilot can fly an MD-11 2,160 miles with the wind, and at the same time she can fly 1,920 miles against the wind. If the speed of the wind is 30 miles per hour, find the speed of the plane. So this is going to be just like the river. Okay, we've got distance, we've got speed. Okay, so we've got against the wind, we've got 1,920 miles. With the wind, I've got 2,160 miles, and the speed of the air is 30. So against the wind, it's going to blow against us, obviously. Against the wind, it's going to be a subtraction, and with the wind, it's blowing with us. It's going to help us. So that's going to be the 2. Hold on. Screen keeps freezing, and then I can't see whether or not you can see. Okay, so set up our proportion. I've got, let's just do it right down here. That looks awesome. So 1920 over 2160 is equal to x minus 30 over x plus 30. You technically could do it this way and set them equal. Okay, I could do 1920 over this equal to this over this, but then I have to multiply x's and get quadratics and do all that. That's no fun. Don't do that. Okay, number over number equal to the x over the x, and that way when I cross multiply, I'm not multiplying x's together. Okay, so here I've got 2160 times x minus 30 is equal to 1,920 times x plus 30. Okay, let's go ahead and actually multiply that out, which I'm going to do up here. Okay, I'm going to do this up here. So when I distribute both of these, I end up with 2,160x minus 64,800 equal to 1,920x plus, my paper's cut off, so let me do this real quick. 1920 times 30, 57,600. Big numbers, yes they are. 57,600. I didn't leave myself room either. Okay, so now I'm going to move this one over, 64,800, add that to both sides, and subtract the 1,290 from both sides. 1,920, said that backwards. Okay, so I get 240x equal to 122,400. Divide by 240, divide by 240. X is equal to 122,400 divided by 240. No, I cannot do that in my head if you were wondering. 510 miles per hour. I guess I could, but I'd be really slow at it. Okay, so 510 miles an hour is how fast I would be flying if the air was not moving at all, which is rare, by the way. But again, go back to logic. Even if you know nothing about flying planes, hopefully by now you know that if it was going 51 miles per hour, your plane is crashing. Okay? Hopefully you know at least that. If you got negative, your plane has already crashed. Okay? So think logically about these things. 510 miles per hour sounds pretty good. It's obviously a lot faster than a car. That's why we fly. Okay? That, I believe, is the end of problem solving. I know that is a lot. Okay, there are several different methods. Let me go back through them extremely quickly. Okay, starting with, we did just the basic proportions where you have, okay, for instance here, this was, I bought these for this amount, and how many are these, if I buy this many, how many is that going to equal to? Okay, straight proportions, 110 calories, 28.4 grams. How many calories for 42.6? These are just straight proportions all the way down. Then we did the triangles, similar triangles where you have to actually choose your sides. You always choose your variable side and the one that goes with it, and then just pick another side. Be very consistent. Small over large, or small over small equal to large over large. Whatever you do, just be very consistent. Not only with whether it's small or big, but with the sides that you actually set it up. Okay, numerator, numerator, denominator, denominator. Have to be consistent. That's the biggest part about these triangles. Okay, so that was all of the triangles. And then we did, oh, I went backwards there. And then we did, there's so many, the work rate ones. Okay, one job for however much time, one job for however much time for the two different people. Set those, add those together, and that's equal to one job for the total. Okay, and it's always going to be that no matter what the jobs are. Okay, one person, we got one job for that much time, plus one job for that much time is equal to one job over the total time. It'll always be that. Sometimes they'll give you the total time and ask you how long it takes Frank or Sam or whoever. Okay, so you might have an X on this side, but the process is still the same. Find your common denominator and then solve. Okay, we also looked at the car, truck things. Okay, distance ones. When you're setting them up, it's best to draw this out where you list out your two things, car and truck, or walker and jogger, or whatever the two things are. Okay, and then your two different variables, so distance and speed, or whatever those are. Okay, write them actually out. The big thing here is going to be able to put an X for the one you know nothing about. Okay, set up the other one with respect to that. So 20 miles an hour faster is what we had there. Once you get that, set up that proportion, cross multiply. Okay, then we went to the upstream, downstream. These are going to be the harder ones just because of the upstream, downstream tends to throw people off. You just remember you set up your little graph just the same. My distances, those are easy. When I talk about speed, okay, if I'm going upstream, I'm subtracting the speed of the river. If I'm going downstream, I'm adding the speed of the river. Okay, same thing with the plane. Against the wind, I'm subtracting the speed of the air. With the wind, I'm adding the speed of the air. Okay, so that's the kind of stuff that you're looking at. That's going to be proportions. The next one we'll look at is simplifying complex fractions.